Alright, Math 3, Test 2, Logarithmic Functions Review. So, this is the same style the test is going to be in. So if you can do this, you can do the test. My suggestion, pause the video if you haven't done any of these problems yet. Try to do them, treat it as if it were the test. Then go watch and see where you made your mistakes. Alright? So 1 through 4, we are simply just rewriting them. And remember, from the log format, log base b of x equals y, the exponential form just becomes the base b of y equals x. So for 1 through 4, that's all we're doing. So my base of 3, so I go 3 to the 5th equals 243. Okay, and that's my answer. Then number 2, 14 is the base, so it becomes the base. The output is -2, that's my exponent, equals 1 over 196. Now, if we're going backwards, we just go, the base of my exponent becomes the log base. The output becomes the input, 1 over 121, equals the exponent, -2. So the base, 8, so we go log base 8 of 64 equals, and that equals 2. Now, 5 and 6, we're going to evaluate each expression, and so we want to use these ideas that the log base b of 1 always has to equal 0, that the log base b of b always has to equal 1, and that the log base b of b to the n always equals n. Okay, so if I look at this one, 1 over 36, I know that 36 is related to my base, it's 6 squared. And if it's in a fraction, that makes it a negative. So we really have log base 6 of 6 to the -2. So what does that equal? Has to equal -2. Okay, number 6. Log base 525 is really 5 squared. So log base 5 of 5 squared is also 2. Okay, now for the last two on this one, 7 and 8, we can just type these into our calculator. Okay. So remember, if we're typing them into our calculator, okay, we type in we can hit Control and then this button to get the log, or we can hit this button which brings this up, and we type in the log, and then we just, in the calculator, type it in as a log. So when I do that, as you can see, we get log base 7 of 5.7 is 0.8944, rounding to the nearest thousandth would be 3 places, so 8.894. Then 0.6309 would round up to 0.631. Okay, so that's for 7 and 8. All right, now expanding. So for 9 through 12, where we're expanding, and through 13 through 16, where we're condensing, we are using the rules, right? So we have the product rule. Okay, which, remember, we take log base b of 2 or more numbers multiplied together. We can distribute that log between them, and however many there are, give them their separate log base b with addition in between them all. Okay, we also have the quotient rule. Same idea as the product rule, but instead of dealing with multiply and add, we deal with division, which we can separate then by subtraction. Oops, that should be log base b of x and log base b of y. And finally we have what we call the power rule. Okay, so this one we go log base b of any number raised to a power. That power can just be multiplied in front. Okay, so when we're expanding, we start with this side and we try to get to the other side. When we're condensing, we start at the longer side and we're trying to get back. Okay, so one other thing to remind ourselves, a square root or any root is actually a fractional exponent. So really that's log base 10. Also remember, if there's no number right here, we assume it's 10. So of a to the 1/2, so we use the power rule and just bring that down in front. So it becomes 1/2 times log base 10 of a. Okay, 10, same idea. That 2 is going to jump down in front. So 2 times log base 10 of u. Now 11, log base 10 of x times y becomes log base 10 of x plus log base 10 of y. And number 12, now we've got a few things going on here, don't we? So first thing I want to do is take that 3 and I want to distribute it through. And remember, when you take a power to a power, it's multiplication. So a raised to the third, that's like a to the first, or if that were a to the second, that would become a to the sixth. We only add when we have the same bases. That would be a to the fifth. Okay, see the difference? So we'd get log base 9 of a cubed over 3 times 3 would give me b to the ninth. So first thing I should notice is the divide. So I want to split it up using the quotient rule. So I get log base 9 of a cubed minus log base 9 of b to the ninth. Then we're going to use our quotient rule, or wait, we did use it. Now we're going to use the power rule to finalize this. So 3 jumps down and I get 3 times log base 9 of a minus this 9 jumps down, 9 times log base 9 of b. And that's my answer. Okay? So when we're condensing, we do the opposite. Okay, notice this one, we've got the 3 out front, so that's our power rule. So we're going to bump it up there and have log base 7 of u cubed. And that's all we do. Okay, in 14, notice we have the minus here, so we bump it back to division. So log base 9 of x divided by y. The first one is always on top, second one on the bottom. And that's as far as we can go. Plus sign means we times log base 2 of x times y. Okay, now 16, we've got a few things going on. So first, we use the power rule and bump that up. So I have log base 4 of x plus log base 4 of y plus log base 4 of z to the fourth, or squared, sorry, 2. Now there's all pluses in here, so we're using our product rule. And I just go log base 4, one of them. And so I have x times y times z squared. And if I want, I can put it in parentheses. And that's all we have to do when we condense things, okay? So now graphing. Alright, so for graphing, remember we go off the parent graph, which has that x-intercept at 1 and an asymptote at the y-axis. And then it curves up like that. And the base only affects how quickly it curves. The higher the base, the sharper the curve. Okay? So on this one, we've got a 4 on the inside. Okay, and if you remember, that was the same thing as log base 2 of x plus 2. So that vertical move up would just change that point up. We keep the asymptote where it's at, and we just curve it up like that. Okay, now 18 has the natural log, right? Log base e. So it works the same way. E is about 2.7, so that kind of gives you an idea. Now we've got a negative, this one we were throwing you off. Remember, that reflects it over the x-axis. Okay, that 3 in front kind of stretches it. Okay, and then we've got the plus 2. So from right here, okay, we're going up 2, but we're also reflecting, so it's really down 2. Okay. We didn't move it left or right, so we still have the asymptote at the same place, and it's reflected, so it's just kind of going backwards like that. Okay, and remember, I'm looking for just the basic asymptote and kind of where one point would be on the graph. So if you use technology to graph it, that is just fine by me. Okay, so 19. Okay, now we've got a horizontal movement of 3. So our asymptote is going to move to the right 3, because remember, it's opposite, and then down 5. So that point moved to the right 3, right? Starting here, 1, 2, 3, down 5. 1, 2, 3, 4, 5. Okay? Now, it's not negative, so it's just going to curl up like this and shoot over. Okay? Then that final one, left 4 and up 2. Because it's opposite on the inside, that horizontal movement, so my asymptote's at -4. from my point right here, we go to the left 4 and up 2. That's the point where it's going to cross. Start right here, curve it up. That's basically it, guys. So this shouldn't be too long of a test. You guys should be able to knock it out of the park as well. So there we go.